We finished 3 presentations now. We are almost 50% of the time. Okay, shukran. Before we move to the, our next speaker, I would like just to attract the attention or enhance the presentation, enhance the discussion with this slide. In the very beginning, I presented one slide, and in this slide, I did talk about the 3 corners of the nexus: water, food, and energy. The question now is, could we have a conflict between water, food, and energy, or there is no conflict between them? If we look at the regional level, and for Egypt, if you look at the Eastern Nile Basin, we will find that we have 3 countries, Ethiopia, Sudan, and Egypt. They are connected with the Blue Nile and the main line. If we start applying nexus, we have water. The water can be used by constructing dams to generate energy. So we have a connection between water and energy, straightforward, by producing energy using dams. We don't like to forget that the water used for electricity is a non-consumptive water. The water can be used again. But the conflict is, how about drought periods? How the water will be used? Would you release water for the downstream to produce food, or to keep the water with a high level in order to generate energy? So in that situation, we have a conflict between water, energy, and food. So this is one issue which is very important. As a result of that, you may find Egypt is covering the food gap by the virtual water, which we need about 34 PCM. So applying nexus in that context, in that case, is very important to look at it. One more point here is the land grabbing. Land grabbing, as you see here in the lower photo, as if you are taking part of the Africa outside. When you start using the water for biofuel, instead of using the water to generate or to produce food for the people to live in, and use the water for biofuel to generate energy, this issue has to be looked at carefully. And this is the issue which we are facing here. If you look at the figure here of Africa, you'll find many countries are grabbing the land of Africa for producing biofuel or feed for animals and so on the expense of the living or the life of the people downstream. And we have here some numbers. Just I wanted to shed some light on this issue in the context of nexus. Our next speaker is Dr. Manuel Sapiano. Dr. Sapiano is the Chief Executive Officer of Energy and Water Energy in Malta. He coordinates a team of experts with responsibilities of formulation, evaluation, and implementation of national policies. He also coordinates EWA identifications. Mr. Sapiano is a hydrogeologist with a specific specialization in island and coastal hydrology. He had led agency water policy unit. He has been involved in implementation process of EU water. So the presentation of Dr. Sapiano is Energy Management in Water Production and Wastewater Treatment Case Study, Malta. Would you please proceed, Dr. Sapiano?
And yes, that's good. And whilst sharing the presentation, So I would definitely like to thank the organizers who had, I am sure, a very difficult task in perfectly organizing this forum with the current unfortunate conditions which have added strains when one is organizing such activities. Therefore, looking at energy, the water energy nexus, and also trying to extend it to the energy, water, and food nexus. My presentation will deal with present the results which we have made in a study, but to try to link the energy used in water and wastewater treatment. Therefore, I'll try to move to the next slide if it leaves me. Okay. So we know that to produce water, to distribute water, to collect water, we need energy. In fact, looking at Malta, being an island, being highly populated, having a high population density, we actually use around 6% of our total energy needs to undertake these services in the water sector. Obviously, we depend a lot on desalinated water, so the desalination water. More than 60% of our drinking water which is supplied to homes, to industry, is produced by desalination, and desalination alone accounts for around 55% of all the energy used in the provision of...
Mr. Manuel?
Yes?
Sorry. Could you please remove the sticky note because the screen will show gray rectangular over the presentation?
So, is it working like this?
Yes, perfect. Thank
Perfect.
you.
Oh. So that helps. Thank you for highlighting. So basically, we are looking at a situation where desalination consumes a lot of energy, but also we are looking at other sectors in the let's say water services sector, which also have quite a significant energy use themselves. Energy costs. And there is a cost for energy. And when we looked at how, let's say, the cost incurred by our water utility to provide these services, the energy cost utility accounts for around 25% of the total costs of the utility itself. And therefore, if we are going to look at financial sustainability in the provision of water and wastewater services, the fact that energy accounts for around 25% of these costs leads to it to becoming an important consideration, because energy efficiency can lead to lower costs, and lower costs obviously can lead to lower costs on our people who are actually being provided by these services. If we look at desalination, so if we look at the cost for producing 1 cubic meter of water, desalination accounts, the costs of electricity account for around 70% of this cost. So it is very high. Therefore, it makes a lot of sense to invest in energy efficiency. And I have to say that there have been a lot of investments in energy efficiency in Malta. We have managed to reduce the energy required for the provision of water services of desalinated water significantly. We are now reaching, let's say, a requirement of around 3.8 kilowatt hours per cubic meter. Going back 10, 15 years ago, this have been in the region of 7. So energy efficiency is important, but still at energy efficient levels, electricity accounts for a high percentage of the cost of desalinated water. We operate a lot on energy recovery systems, and so therefore the brine which is going out of the desalination plant is energy sourced from that brine and put back in the system, therefore requiring less input energy. And also we operate on management systems on the plants to try to always operate those membrane lines which are the most energy efficient, and therefore once more trying to reduce the consumption of energy in these plants. If we look at groundwater, interestingly, still once more, pumping of groundwater requires electricity. And a high share of the cost of groundwater is electricity itself. However, given that we're looking at lower energy needs for the pumping of groundwater, we're looking at energy needs of around 1.2 watt hours, basically on average for meter. Therefore, that cost of electricity is less and the margin for saving is less than desalination. But I think it is important to note that it is not just desalination which requires energy, but it is also groundwater pumping which requires energy itself. In the groundwater perspective, given that energy goes mainly to pumping equipment, also the margins for the reduced energy are quite difficult, but that energy is there in itself. Looking at wastewater. So, as many countries are required to treat our wastewater to discharge to surface water for the marine environment, it is an environmental obligation because we want our waters to be clean, but this once more comes at a cost. And it has an energy consumption, particularly wastewater treatment. Let's say if we look at the wastewater sector, wastewater treatment, so the treatment plants consume around 70% of the energy, whilst the collection of wastewater in the sewer network consumes the other 30% of the network. What one needs to pay attention to is to try to limit the water flowing in sewers. So if we are more efficient in water use, there is less water to. If we, in the case of Malta, we have sewers below sea level, if we reduce infiltration of seawater in the sewers, we can also decrease the energy needed. In fact, from this point of view, and this is important for coastal areas, wastewater with a high salinity can lead to an increased requirement of energy by around 75%, because you need to blow more air, you need to you need to have the water, have saline wastewater resident for a longer time in the treatment plant, and therefore once more energy consumption goes up. However, we need not to look just at the production side. We need also to look at the demand side. Every cubic meter of water which we save, which we do not use, means a cubic meter of water which we do not need to produce. And that is once more less energy. And that also requires less energy. In fact, I can highlight that leakage management in Malta has resulted in a significant decrease in the water demand, almost by 40% over the consumption, the production in the year 2000, and therefore all that has also contributed to lowering the share of energy for the water sector to the 6% which I quoted, which in 2000 was around or over 10%. We also need to look at how we use water in the home and also other areas, because yes, we do use water, we do need water to, let's say, to undertake our activities, but in using water, we also use hot water. So we have energy to use the water, we have energy needs to bring the water to our home, but we also use energy to heat water in our home. And in fact, around 45% of the volume of water used in the home is actually hot water. So water which has been has used energy. In fact, if we look at, for example, at shower water, so containing our showers, our shower time, reducing the water which we use in our showers by using efficient fixtures, by reducing the time we spend to what is necessary, actually not just reduces the water volume, but it also reduces the amount of energy used. And this is another linkage which one has to look at when considering water and energy. In fact, the energy saving desalination plants, and also other efficiency measures have moved to Malta, have made it in the last years, whereas before water was the most energy consuming appliance, call it, in the home, today that is the fridge, because of the efficiency gains in the water sector. Another aspect which I refer to is distribution of water. Distribution takes into, let's say, uses around 20% of all the water used for producing, or the energy used for producing water. So there is an energy use there. And in particular, one should look at heights, so trying to limit unnecessary pumping water to unnecessary heights, but also limit friction in pipes. So old water networks which have friction can significantly increase the energy consumption almost tenfold of required to distribute water. In fact, we have been doing this exercise because we are working to transform our water utility into a net zero water utility. Basically, from a volumetric perspective, we're looking at a utility which contributes back to the water environment as much water as it takes through different activities, but also we're looking at a utility which can address its increased needs for production through energy savings and therefore have a net neutral impact on its energy consumption. Finally, and I will conclude with this slide, all these numbers tell us that energy efficiency plays a very important role in planning how we use water. And also because it affects the financial sustainability of providing water services. We can look at production, distribution of water, collection and treatment of wastewater. Also, we can look at the way people use water, and therefore we need to work towards comprehensive management frameworks within the whole urban cycles or holistic solutions, which can ensure an effective use of energy in water services provision. Thank you.
Okay, thank you very much, Dr. Sapiano.